Hello sir, I hope everything is good there. My name is Jai Chaturbai Kakadia and my student ID is 2230044. Today I am talking about a neural network applied on a image dataset named CIFAR-10. So, and this practical side is done in a Google Colab notebook. So first step is import the relevant libraries like pandas, numpy, matplotlib for the visualization, keras for the download the dataset, seaborn, tensorflow, and the other libraries like splitting the data for splitting the dataset, trend test split, keras, sequential for the neural network, and these are for the layers: input layers, dropout, convolution, convolutional layers, dense layers, flattened layers, and other and the other also like accuracy score, confusion matrix. I import warning to ignore any warning messages because it not looking good. The second step is to load the dataset. So I download the CIFAR-10 dataset from Keras libraries and load it by using this keyword CIFAR-10 load data, and we can see that it is downloaded from www dot this link. And then for the backup, we created four variables and store all the data: xtrend, ytrend, xtest, and ytest. To showing the xtrend safe, x in xtrend variable there are 50,000 records, and the same label in ytrend. CIFAR-10 has the shape of the CIFAR-10 is 32 by 32, and because it is color image, so there is one more dimensional, and it is 3. To printing the first 25 image with label, first of all we declare the class name and save all the attributes names like plane, car, bird, cat, deer, dog, frog, horse, sheep, and truck. And by using the for loop, we printed the first 25 images, which is frog, truck, and car, and that all. So these are the first 25 images in the uh, CIFAR-10 dataset, in specifically xtrend dataset. So other step is data pre-processing. Data pre-processing is very important for neural network or any data mining techniques, or um, applying applying classification methods. So it is very important steps in pre-processing is very important step. The first step is normalization. So as we can see, the before the normalization applied, x10 is looking like this error, so it is not normalized. After that, we normalize the dataset using by divided by 255, and we normalize the pixel values in the range of 0 and 1. And as we can see, after applying the normalization, all the values are in between 0 and 1. uh, the second pre-processing step is one hot encoding. So before we applied one hot encoding, the first label is 6, and after applying one hot encoding, the our label is looking like this array. So first label is 6, so all the value are 0 except the 7th position, because array start from 0. So our label will look like 0 0 0 0 0 0, and the 7th position it should be 1 because it shows the label is 6. So our all the label is converted in like this error. So if label is 4, then the first 4 position will be 0, and the fifth position of the label should be 1, and other and all other error values will be 0. So it is one hot encoding. Then we split our dataset into split our train dataset into training dataset and validation dataset. So we splitted our X train and Y train into X train, X validation, Y train and Y validation dataset with the size of 25%, and the random state is 42. Here we can see the shape of all the dataset. Training image shape is contains 37,500 records, and the train label is also same. Our validation images and label shape is contains 12,500 records, and our test dataset contains 10,000 records. So now we are going to apply convolutional neural network. So first we first we create our convolutional neural network with Adam optimizer. So we use the sequential models, and here is the architecture of the model. The first layer is a convolutional layers, and the input shift is 32 by 32 with color image. Activation is ReLU. Then we add the pooling layer. After that we add the convolutional layer with 64 neurons. Then we again add the pooling layers, and we again same convolutional layers with 64 neurons, and activation is ReLU. Then we add the flatten layers, and at last we add two dense layers. The first dense layer contains 64 neurons, and the last dense layer contains the 10 neuron. Then we compile the model and feed the data. Here is the summary of our model, and then we feed the 25 epochs, and here we can see it is the result of 25 epochs, and here we can see the model accuracy with training accuracy and validation accuracy. So we can see that training accuracy is very consistent and very high. However, the validation accuracy is not too much perfect, so it is the best example of overfitting. When we come to the model 1 loss, the loss is very consistent and very lower, which is very good. But on the other hand, validation loss is slightly uh, increased. So we can say that model 1 is not working too much, and it is the best example of overfitting. Then we experiment HCD optimizer instead of Adam, and here we apply the same model, and here is the summary of the our second model, but at this time we use the HCD optimizer. For that, uh, we import the HCD from keras.optimizer. Then we compile our second model and feed the 25 epochs to validate our data. Here is the model accuracy. So it is very consistent, from the both side accuracy and validation accuracy, there are no changes in this model. And I think we add mm, and in the model loss also there are no changes. So I think it is the perfect example of underfitting. uh, it is not it's not good. So after that I created a model 3 with different learning rates and early stopping. So I experiment uh, I did experiment with different learning rates like 0.01, 0.001 and 0.0001 with Adam Adam optimizer and categorical cross entropy loss value. Here is the coding of the in for loop. We train the model, fit the model, and apply the early stopping also, and then we plot the accuracy. So here we can see the uh, graph of the uh, graph of the Adam optimizer, our model 3 with different learning rate, which is 0.01, 0.001 and 0.0001. As we can see in the graph, the learning rate 0.001 is very effective, but it is on a training dataset. For the validation dataset, yes, validation dataset, in a validation dataset also, learning rate 0.001 is better than all the other learning rates. And here is the loss of our model 3 with different learning rates. In for the loss, the learning rate 0.001 is very effective in both training values and the validation values also. Then we add more parameters and we add the dropout layers. So we add dropout layers after the pooling, after after first two pooling layers, and and we add third dropout layer before the first dense layer. It will drop out the 20% of the layer if it is not effective. Here is the summary of the our model 4. Then we compile and apply early stopping, and we store the result in the variable history4 and feed the model. We applied 20 epochs. The model here we can see the model accuracy and with the value of the validation accuracy and training accuracy. So this model is working perfectly. The validation accuracy is consistent and it is higher than the training accuracy. Let's see the loss values, loss graph. Yes, the validation loss is lower than the training loss. So this is the perfect model for our CIFAR-10 convolutional neural network. For the prediction, uh, we predict on the test dataset, and in new variable we store the value of x test full. In x test full, there is a testing dataset. We created this variable for the our backup, Then we predict the model 4 on the testing dataset and print the variable y probe, which is prediction values, and here is our prediction value. For using the argmax library, uh, this argmax is used for the highest probability, and we created a ypred variable and applied argument max for the highest probability or highest prediction. Then we print the classification report, and our model for accuracy is 44%. Along with this, we can see the precision recall, F1 score, and accuracy. Here is the confusion matrix of our model 4, which is the perfect model uh, uh, in this collab notebook. For in another experiment, we use the testing dataset instead of validation dataset. So our model is same with the top outliers and earliest stopping, but at this time we use the testing dataset instead of variable x well and y well. Let's see what happened. And at this time, I applied 15 epochs. Here is the all the epochs and graph of the accuracy. So graph is saying that it is also pretty good on testing dataset. The loss is also good. Let's predict the result now. So this is our backup variable x test full, and in this model our accuracy is 46%, which is higher than the previous model. In previous model our accuracy was 44%, and in this model our accuracy is 46. In the epochs we can see that our validation accuracies go up to 65%, 66%. The highest is 66%, 66.18%, which is which we in this model we used validation us we used testing dataset instead of validation dataset. So this is not a validation accuracy, I think it's a testing accuracy. Then we use the LXNet architecture on the model 6. LXNet architecture is very popular architecture in the uh, neural network. So it contains the convolutional layer and max pooling layer with the different size. The first convolutional layer contains the filters 32 and the kernel size is 44. Activation is ReLU. And the second convolutional layer has filter 256 neurons. Then we add two more convolutional layers with the same neurons, 384, and max pooling of size 2. Then we add flatten layer. Then we add dense layer of 496 neurons, and dropout rate is 0.5, which means it model will drop the 50% of the neurons if it's not connected well. Then we again add the dense layers with the same size and dropout layer with 50%. And at last uh, we add the output layer with the size of 10. So this structure is the LXNet architecture. Then we compile the model and feed the uh, 15th epochs. Let's see the graph. In this graph, after some time, it will it it will consistent. There is no changes. As we can see, the model loss is increased, but after that also, this is the best model. This best model. Let's see. Let's apply. Let's predict the result on a testing dataset. The method was the same. We predict the our backup data x testful. Then here is the classification report, and it is the highest uh, accuracy in this work up to we see. So accuracy is 49%, and we can see the precision recall and F1 score of all the attributes. Uh, After that, I print the confusion matrix of model 6, which is LXNet architecture. Then we calculate the accuracy of each class on LXNet architecture, and here is the result. The overall accuracy is uh, around 50%, which is the highest accuracy over the 6 model. Accuracy for class 0 is 79.60, is class for class 1 79.20, and so on. So here is the all the accuracy of the 10 attributes, and here is the end of my practical work on a CIFAR-10 convolutional artificial neural network. uh, thank you thank you so much for your valuable time. Thank you.